Okay, back with another video, but today we're dealing with Euclidean geometry. So what we're going to do is I'm going to show you how to analyze a question and then how to answer it based on your analyses. So what we first need to detect is that they told us that O is the center of the circle. So when they tell you that something is the center of the circle, you only want to think of your center theorems. I don't want you to think of all millions of them. Okay, I know I'm over exaggerating, but sometimes it does feel so overwhelming that there's just so many to remember. I want you to categorize them. So with our center theorems, we need to know angle at center is equal to 2 times angle at the circumference. That's our main one. We also have angles in semicircle and possibly our tan perpendicular to rad. All right. Yes, there are the other ones where we have that a line from center is perpendicular to chord and that the line from center bisects the chord. But if I look, I don't have a chord going through one of my radii, so therefore I won't be using that theorem. So they gave us that angle P is 51 degrees. And then they said, and VAT is a tangent. Now, because they've told us that it's a tangent, now we know it's very likely that we're possibly going to use tan perpendicular to rad, or we're going to use our tan chord theorem. And yes, there is the third one where tangents from same point, that we know that they are equal, but I've only been provided with one tangent. So therefore that theorem I'm already excluding. Okay, then it says you need to find the size of the various angles. The first one being TAO. So you're going to go TAO. Do you see that that is going to our center, meaning that this line is a radius and this is a tangent? So that matches up with our theorem tan perpendicular to our rad. So tangent perpendicular to radius in full, meaning that that angle must be 90 degrees. Therefore being 90 degrees because of tan perpendicular to rad. Now, the only thing I need to mention here, reasons are one of the most important things to remember when you are doing your Euclidean geometry. Everything in life has a reason. And just like that, in math, everything in Euclidean geometry has a reason. I need to know how you got there. It doesn't help you give me the right answer, but we have no idea how you landed up at that position. Okay, now once we've done it here, I always ask my students to put it back on the diagram, but luckily I've already done that. But that should be like your step 4, is to always put it back on your diagram, because I don't want you to be looking through your answers to find what the size of that angle is. If you already have it on your diagram, you can then just go and refer back. Okay, now on to the next one. AOB. We have AOB. So they want the angle at the center. So angle at the center is 2 times angle at the circumference, is the one that should be going off in your head, the one that has an alarm bell. But now, how does that look? So when it comes to angle at center is 2 times angle at circumference, it comes in 3 different forms. The main one that we have is going to look something like this. It's as if 2 arrows are pointing in the same direction. Do you see? That arrow is pointing to that one. That means the angle at center is 2 times the angle at the circumference. The second one that we have almost looks like our bow tie, our angles in same segment. But this is not on the circumference. And therefore, this angle at center is 2 times angle at circumference. And then the really tricky one that gets you guys confused is if it looks almost like it is a cyclic quad. This exterior angle is twice the size of that interior angle. Okay, so if you need to take a screenshot, do what you got to do, but you need to remember these three variations. Now, if we look at our diagram, option 1, 2, or 3, okay? Yes, I have this option where is option 3, but I don't have the value of Q. Yes, I can find it, but there is an easier way of doing it. Like I said, as long as you show me all your steps and your steps are correct, it doesn't matter if you were in Johannesburg and you're trying to travel back to, let's just say, the Free State, and you went through Cape Town to the Free State instead of just traveling directly to the Free State. Okay, doesn't matter which pathway you took. Some are longer, some are shorter, but the steps are vitally important. So yes, we could have done this one for angle at center 2 times angle at circumference, but then we still need to find this angle doing 360 minus, which would just be really complicated. So why don't we do the first option? Do you see we have the 2 arrows? So that shows that this angle here is twice the size of angle P. So let me erase all of this. That angle AOB is twice the size of P, which is therefore going to be 2 times 51 degrees. Degree symbol is very important, which is therefore 102. That theorem was angle at center is 2 times angle at the circumference. All right, and like I said, once you've done it and you've completed it, put it back on your diagram. Great stuff. Now we're going to AQB. AQB. Now look at the bigger picture. Do you see they've provided you with a cyclic quad? And we could use the opposite angles of a cyclic quad in order to solve for Q. Okay, and if you remember this theorem, it states that the opposite angles of a cyclic quad are supplementary, meaning that they add up to 180. So therefore, AQB must be 180 less 51 degrees, which, if you guys type that into your calculator or do mental math, should be 129. Okay, and don't forget the last step. Once I've written it down, where does it go? It goes to my diagram. All right, now let's do the next. BAT. BAT. This might be a little bit tricky, but look at what it's touching. I'm not doing anything with the center, so these center theorems I don't need to care about right now. But it's touching a tangent. So all of my tangent theorems should be doing alarm bells. And technically, from a process of elimination, it's not tan perpendicular to rad, it's not tangents from same point, but because it's touching our tangent, it should be tan chord theorem. Now, if you're someone who struggles with tan chord theorem, what I would like you to do is place your fingers. Okay, so this is going to be your finger. You're going to place your finger on this end, and you're going to place your finger on the other end of the chord. Where your 2 fingers meet up, that is the angle that is equal to it. So therefore, this angle is going to be 51 degrees, because if I take my fingers and I put them at the edge and I bring them together to the edge of the circle, aka our circumference, where they meet up, that's the angle that's equal to it. So therefore, BAT is equal to angle P, which is 51 degrees, and you have to have a reason. Tan chord theorem. Okay, and then the last one for today. We need to find OBA. So OBA. Now this looks very confusing and can be very alarming if you're not dissecting it. All right. What I would do as a hint for you, if you are trying to solve this step by step and pausing before I do the answer, you need to notice that OA is equal to OB because they are radii. And because of that, can you see that we have an isosceles triangle? which means that angle OBA is the same as angle OAB, if that makes sense. OBA is the same as OAB. All right. And your reason for that would have been angles opposite equal sides because it's an isosceles triangle. Now, because of that, we could therefore say that OBA is equal to 180 degrees less that 102 divided by 2. And that would therefore give us our amount of 39 degrees. Okay, and that would have been the sum of angles in a triangle. Perfect, meaning that this is 39 degrees and that is 39 degrees. Perfect. I do hope that this video you found it helpful. If you did, please do like and comment down below. If you'd like any new videos, you're more than welcome to comment as well. And I'll see you in the next one.